Learn DBT with an example. Have you ever wondered how data engineers stop their companies from losing money due to bad data? We are talking about DBT, the Data Build Tool. It is the industry standard for taking raw, messy database tables and transforming them into perfect, structured data for dashboards and machine learning. We're going to build a real-world pipeline for a company that sells products using barcode scanner. To make this realistic, we are going to build our pipeline to solve three classic data engineering challenges. First, the data quality. Hardware glitches, so we need to clean up duplicated barcode scans. Second is historical tracking. Employees get promoted mid-month, so we need to track their changing roles over time. Third is business logic. We need to apply different commission rates based on those changing roles. DTV layers. A DTV project is composed by the following layers. Staging layer. The goal is to standardize raw data. The work on this layer consists of renaming columns, casting data types, and removing duplicates. No joins allowed. Intermediate layer. The goal is to serve complex logic and math. On this layer, it is possible to perform joins and calculate business logic. Marts layer. The goal is serve data to the business stakeholders. Here, the finite table were structured for reporting, dashboard, or data analysis. For this tutorial, we are going to use a simulated retail database. So, it has 5 core tables: clients, employees, products, sales for the receipt headers, and sale items for the individual products sold. Before creating our models on DBT, we will check some files and directories. The first one is this, profiles YML. On this file, the credentials for database are set, so we can set here the database, the threads that we are using to connect to that database, password, etc. And then we have some folders, some important folders like models, where all the layers are defined. The snapshot folder, which is important when we will check how snapshots are created, and the tests, where our tests are created. Inside models directory, we have the 3 levels of layers: the staging layer, intermediate, and Marts. The staging, it's kind of different because it will link to our database directly using a function, a DBT function, to link to our source, our database source. On intermediate and Marts layers, we can use the models that we already create on staging, so this one is a kind of different. We will start creating a file named sources YML, and inside this file we need to specify some values like version, sources, the name of the source, in this case is raw, app data, then the schema on the database that we will use, a brief description, and the tables that we will use. Okay, now the next thing is to create our first model. To do that, here we can create a new file called SCD client.sql. So here we'll define our sources. Here's some cast of a datetime field. Okay, now let's check this function, source. This is a function that DBT uses to link our model to the database table. Here is the name of the source that we are using, which is this one, and here's the table name, which is this one. So we make a link called resources or sources. I'm sorry. Let's rename this to just source, and then we use this name here, and that's all. So let's build this model. To do this, we can execute the command dbt run. To do this, the command that we will use is dbt run. Executed this on a Docker container, so that's why you can see the extra parameters. So let's execute. Seems that everything is correct, but let's check on our database. Here in our database we have this schema row where all our original tables are stored, as you can see, and then there is a new schema called DTV development where a view was created. So check this one, STG clients. Let's check what data we have on this view. And check this. The names, I mean the column names and the data were changed according to our model definition. So as you can see, we have our first model. Let's create the other models. Now let's go with products. And some test. Now let's go with sales. And some cast. Finally, sell items. And some test. Now let's build into the database. Okay, there is an error on SDG sales. Let's check here. I forgot a comma here. Let's build again. Okay, let's check the database. Okay, here is, let's check the data. Okay, okay. Okay, looks good. Now let's continue with an intermediate model. So here we are creating a new file called int files by employee. Now here we add some Marts. Okay, now here are some changes. We are not using the source function anymore. We are using the function ref. Ref allows us to use another model that we already created, like SCD sales. So it's a way to determine the dependencies of each of these models. So we are reusing the model definition that we already made, and we can reuse this int sales by employee in another model. It's a way to construct without duplicating the SQL definitions. Okay, so let's build this to check if everything is correct. There is an error. Oh, I forgot the comma here. Let's try again. Okay, everything looks good, so let's check in database. Let's refresh and okay, looks good, and check the maths. Looks good too. Great. Now let's continue with another intermediate model. So let's create a new one. here we will calculate the commission by an employee following the business rule. And here we will add some logic. Okay, here we add the logic according to the employee role. If the employee is a cashier, gets a commission of 2%. If it's a branch admin, gets a commission of 5%. So let's build. Okay, there's an error. Let's check. Oh, I forgot the comma again. Okay, let's check in database. Okay, now check this. Check the total sale, the role, and the commission. For cashier, gets 2%, and for branch admin, 5%. Okay, good. Now let's create a Marts model. Now we'll sum all the commissions for an employee to have a total. Now let's build. There's an error. Oh, here. Okay, now check the database. Now, take a look. We have the total of commissions for each employee. Check this. And we were created using our previous models, the intermediate and the staging models. So that's how can we build a lot of Marts model depending on the business, depending on what the stakeholders require or what the information is the most important for the business. Okay, now let's check this employee, Alice, the employee number 1, and her commission. Let's take a note here. Her commission is 385 and 6. But if you remember, we mentioned at the beginning that there could be some sales that were recorded twice. So let's check if we have those cases in our original table, sale items. So let's check. Now, as we can see, there is 38 items that were duplicated. So in order to have the right value for each commission, we need to fix this before. So let's go to the model. In this case, the model that we need to fix or update is the sale items. So let's make some changes here. Okay, now let me explain this part. Raw number will create a new column on this select with the name rn, and this function raw number will identify if there is a row which is duplicated based on these columns. So if these found rows with these same values, it will assign a number, which is rn. The number will be ordered by this column id. So if there are duplicated rows, there will be more than one row, and the first one will have the number 1 and the second one will have the number 2. So if there is only one row, it will have the number 1. If there are more than one with these 4 same values, there will be rn equal 1 and rn equal 2. So that's why we are filtering to get only rn equal 1, which means only one row, the first one ordered by this column. So let's test. Okay, there is an error. Oh, here is the error. It's unit price, not price. So we can make this change and check. Okay, seems that everything is working, but let's check on the result. So on the total employee bonuses, we should see some changes. Let's execute. Sorry, I have to make an update here. Okay, now let's check Alice again. Our previous value was this, and now we have this 2074. So we have a fix here, and it saves the company a couple of bills. Okay, good. DBT has a feature called Snapshots. This can be applied over a database table in order to keep a history of data changes. To see a use case of snapshots, let's consider the following. In the company, an employee, let's say employee number 1, were promoted at the middle of the previous month. So when the bonuses are calculated for each employee, the math will only consider the last row of an employee, giving an incorrect calculation. For example, if we change the role of the employee number 1, I mean Alice, let's see. Now Alice should have the role branch admin. That's correct. So if we check again the bonuses that the company should pay, Alice now have 685 when as a cashier, Alice has 274. What's the issue here? Well, the main issue is that Alice were promoted at the mid of the month, so not all her sales should have the 5%. So, in order to fix this, we will use the DBT snapshots. To start working with snapshots, we need to set the definition in the snapshots directory here. So let's create a file name employees snapshot. Okay, here we will define the snapshot. Okay, then here some configurations. The schema where the snapshots will be stored, the unique key of the table, the strategy, and the columns that will be checked in order to know if a row was updated. Finally, we get the data. Okay, so in order to execute this snapshot, DBT has a command called DBT snapshot. So let's execute. Okay, let's see what happened. Here in the snapshots schema, a table named employees snapshot was created. Let's check the content. Here are the values before, the values getting directly from the row table, these ones. So when a change occurs, a new row will be created on this table. Let's see. Let's change employee number 1, the role again, to cashier, and execute again the snapshot, and let's see what happened. As you can see here, Alice now has 2 records, one as a cashier and one as a branch admin. The values DBT valid from and valid to help us to determine when this record was active on the row table and when a new value was active. So we have here a kind of history of the table. But let's back one step. Let's back to Alice to her original role. So let's delete for a second this one, okay, and execute again. Good. So now the snapshot has the original value of employee number 1, cashier. Now we will make the update and then we will take a snapshot. Okay, so now as a branch admin, okay, Alice now is a branch admin, we will create a new snapshot. Okay, okay, now to get the value of using a snapshot, it's to imagine that this promotion from a cashier to a branch admin was made at the mid of the month. So let's make some changes on database to have this scenario as a real one. So let's start here. We set employee number 1 to role branch admin, and then we will update the snapshot date to an older data. Okay, let's see. Okay, the value from, where the value was get, now it's at the beginning of the year. Then we change the date where Alice were promoted. So let's use this, and then let's check here. Alice as a cashier was changed on the mid of the month. Let's see here, from the beginning of the year and until the mid of the month. So let's make some more adjustments. Now we will set the new role on the same day. Okay, now as you can see, Alice was a cashier from the beginning of the month until the mid of the month, and Alice is a branch admin from the mid of the month until now. So with this scenario we can check how snapshots can help us to get the right value of the commissions. Okay, because right now the value is this. Let's take a note. Okay, so let's make some adjustments on the model commission by employee here. So instead of using the staging layer, we will use the snapshot, because in the snapshot we have the date where the role was updated. So let's change here. Instead of this, we will use employees snapshot. Then we won't need this, and we will get the ID from the employee directly here. And then we need to build our column names, because the snapshot has the original column names, not the ones that we made on the staging layer. Okay. Now here, employee, which that's correct. Here we don't have employee ID, just employee. Okay, and then we need to add the filters. First, we will get the sale or the date of the sale in order to get the employee role at that moment. And this value is on the valid from column. And here we will get the value, even if it's not the past or current, we will get the right value. So for this one we will use DBT valid 2. Or DBT valid 2 is null. It means the current one. Okay, let's make a review. Here we don't have employee role, just role. Okay. Okay, let's build. Okay, looks good. Let's check on database. Let's execute again the view where the commissions of each employee are calculated. Oh, we need to refresh. Here, the views. Okay. Okay, now check this. Alice, as a branch admin, has a commission of 467, and as a cashier 86. That these are the right values, and if we sum these values are lower than this. So let's note the sum of these two values are this. As a branch admin and cashier. So as you can see, working with this data and understand how the data change, how the business works, can save the company money. As you can see, we have very different stages where the values were changing until to get the right one. So that's why it's so useful, DBT, because it helps us to build a reliable structure where all the business rules or the fixes that we need to make or the quality changes that are needed can be done. Another great feature of DBT is test data. Since data pipelines feed critical business dashboards, we need to ensure that our logic hasn't introduced null values, duplicated, or broken relationships. DBT comes with 4 built-in generic tests: unique, not null, accepted values, and relationships. However, they can be expanded with external libraries. Let's start with the intermediate model, int sales by employee, to make sure that our math is working correctly and that every line item is unique. To do this, let's create a new file named int models.yml. Now we set the following. We set the model name, a brief description, the columns that we're gonna test. And now we establish the rules. Now we can execute a test with the following command. Good. As you can see here, all the rules are passed, so in order to check that the validation is working correctly, we will add some data in a way that the test execution fails. So in that way we can be sure that our validations are okay. To do this, we will make an insert into sale items table with a null value. So I think that I need to make a refresh here, and then okay, now we insert a null value. Let's check. Yeah, here is the null value. Now let's execute the test again. Now it should fail, and that's correct. There is a fail, and it related to the null value that we insert. So as we can see, DBT tests can be elaborated in many ways. So you can wrote some basic validations like nulls, not nulls, values, etc. But also you can use a very complex validation using this kind of definition, but also you can create some SQL queries that can validate data. So it's a kind of different validation, but it also works. So thank you very much to see this video, and please share.